How easy was it to find the point of intersection of those two lines?
Easier when you know how to use the calculator.
It's easier on the calculator, because why? Because it's more precise than doing it by hand, right? But it's kind of clunky, doing graphs works pretty well if you're in that, realm of seeing your solution within 10 of all the different axes, right? But once you have to find lines that are intersecting at 1,000 and 2,000 and stuff, that gets kind of hairy. And so graphing is cumbersome and not a particularly effective way to find solutions. But of course, the book likes to show you the most inefficient way to start with, just because it wants you to understand conceptually what it is that you're finding. And but then we move on to kind of more efficient methods, and that's what this next section is going to be about. So far you've learned how to solve a system graphically. Now you're going to learn how to solve a system algebraically. And it's just a lot easier. You're going to learn two methods. One's called substitution, and one's called combination/elimination. They kind of use both of them. So today you're going to learn about substitution. Next time you're going to learn about combination and elimination.
I remember doing this when I was like 12.
Oh, really? Oh, my gosh. Okay. All right, so you didn't have Algebra 1 already. You did this earlier?
Yeah.
Wow. All right, so let's look at example 1. Okay, they said solve the system using the substitution method. So here, and I'm going to show you why the substitution method works best in this scenario. All right, so here's our system. We're trying to find the xy pair that's a solution to both of these equations. The method of substituting works well when you have a variable that has a coefficient of 1 or negative 1. What's the coefficient of x?
Negative 1.
Okay, coefficient of y, and coefficient of y here. Okay, so any of these would be good substitution material. So let's take this equation 1, okay, and we're going to basically express the variables in terms of one or the other. I'm going to solve for, let's see what the book is doing. It's probably going to solve for y, yeah. Let's solve this for y, okay? I'm going to get y on one side. I'm isolating y. So what do I need to do, Savvy, to get y by itself here?
You need to add x to both sides.
So I'm going to add x to both sides. Okay. All right, Gifty, what am I going to get next?
Y equals x plus 1.
Y equals x plus 1. Okay, so what this is telling me is that y is the same thing as x plus 1. They're equivalent. And I messed around with equation 1. And so just remember this. You never substitute back into the equation that you messed around with. Okay, because everything will cancel out if you do. It doesn't help you. So now what I'm going to do is wherever I see y in the second equation, I'm going to put in x plus 1. Because y is the same thing as x plus 1. Okay? So I'm going to take my second equation, 2x plus y equals negative 2, and now I'm going to substitute in. So 2x plus, but what's y now?
X plus 1.
X plus 1 is going to be popping in here, so it becomes x plus 1 equals negative 2. All right, so Madeline, what do I do next to solve for x? I mean, Lydia, sorry.
Solve for x.
Right here.
Subtract it.
So I got 2x plus x.
Oh,
What do I do?
1.
Okay, and what do I get?
3x.
3x plus 1 equals negative 2. Okay, and then, Olivia, what do I do now?
Subtract 1 from both sides.
Subtract 1. Okay, and then, Madeline, now what do I do?
Divide both sides by 3.
Yep. Okay, and David, what am I going to get?
X equals negative 1.
Negative 1. All right, why did I want to do the substitution? Why did I do that? Can I solve this equation on its own? Without any, because I have x and y? No, I can't. I have to have it all in one variable. So the reason we did substitution here is I got everything in terms of the same variable, which I know how to solve for. Okay? So that's why we did this. So we found out what x is. Okay, so x is equal to -1. Okay, I still need to find out what y is. So what can I do to figure out y? Well, I go back to my first equation that I fiddled around with, and I put in x and solve for y. Okay, so it's all set up. I could just go to either original equation and solve and put -1 in and save, but this is all set up because it says y equals. So y equals x plus 1, but what's x now? -1 plus 1, so what's y going to equal? 0. So my solution now is x is equal to -1 and y is equal to 0. That's the solution to this system. Okay? Let's do one more and then I'm going to have you guys do some. Anybody got questions on this? You guys make sure you have good paper, lots of pencils. You're going to be writing lots of algebra. You can see how much it took to solve this equation. Yeah, you guys are starting to bump into algebra 2, okay? So, all right, anybody got a question on how to do this? Savvy?
What?
Do you have a question?
I'm just trying to write it all down.
Oh, okay. I can give you a second if you're still writing. David, wake up. All right. I gotta let you guys do some of this so that you don't get sleepy. Okay. All right. Equation number. Okay. Example 2. 2x. Okay, and I can't overstate how important it is for you guys to do this stuff accurately. Because if you get one of the variables messed up, you're going to get the second variable messed up. So this is going to be calling upon all your algebra skills now to do this accurately and correctly. So don't be if you drop a negative, you're going to be out in the woods. Okay. All right. So let's look at these equations now. I've got equation 1 and I got equation 2. Which one is best suited for doing a substitution? In other words, which of these equations has a variable that has a coefficient of 1 or -1? Equation number 2, and then that's going to be the x. So we're going to take that equation, and we're going to restate it as x equals something, okay? So, okay, Lydia, what do I do?
Add x.
Well, I'm trying to solve. I'm solving for x.
So you add.
I want x by itself, so I want to deal with this.
Add 4y.
Mm-hmm.
Will we always be solving for x?
No, you can, like in the first equation, we solve for y. You solve for whichever variable has got a coefficient of 1 or -1, okay? All right, so you got x equals, and this is going to be 4y minus 1. Okay. All right, so I messed around with equation number 2. So which equation am I going to have to substitute this into? Equation 1. So here's equation 1. 2x plus 2y equals 3. Okay, so what do I need to do then, Asher?
So you need to put x equals 4y minus 1 for 2x. So
Okay, now keep in mind here, this says, what's happening to the x in here? 2 is being multiplied to it, so that 2 is going to stay there, okay? So 2 is still sitting here, but now instead of x, I'm going to substitute 4y minus 1 in its place. So that means I've got the distributive property I got to deal with, okay? Because it's 2 times x. Well, x is 4y minus 1, so it's 2 times 4y minus 1, okay? And then you got to write the rest of the equation out, okay? So plus 2y equals 3. All right, so David, what do I do next?
Distribute the 2 to
Uh-huh.
the parentheses.
And what am I going to get?
8y and plus 2, or
Okay.
minus 2.
Minus 2. And then I got to bring down the rest of the stuff,
Mhm.
okay? All right, Madeline, what do I do next?
And then combine like terms.
Yep. Okay, so what are the like terms on the left side?
So 8y and 2y, so we'll get 10y minus 2 equals 3.
Yep. Okay, and then Olivia, what do I do now?
Add 2 to both sides.
Add 2.
You get 10y equals 5.
10y equals 5. Okay, and then Lydia, what do I do next?
Divide by 10.
divided by 10. Okay, and Gifty, what am I gonna get then?
Y plus 1 half.
Y equals 5 over 10, which is the same thing as 1/2. Yes. Okay, so what do I do next, Abby? I know Y.
You know Y, we know X, now we're.
I don't know X. So I gotta find X, but I have an equation up here that I set up that says X equals 4Y minus 1.
We
So
put
can I,
the
and I know
Y
this is,
into that one.
yes, so X is gonna equal 4 times 1/2 minus 1. Okay, so, and let me move this over a little bit here. Y equals 1/2. Okay, so what do I do next, Asher?
You multiply the 4 and 1/2.
Uh-huh. And what's the half of 4?
2.
2 minus 1, and so X is gonna equal 1. So what's my point of intersection for these two lines?
1, 1 1/2.
1, 1/2. So X is 1, Y is 1/2. All right, questions? Yes.
So, like, is this a way of finding the intersection?
Yes.
in algebra?
Yes. So this you are. If you were to graph these lines, it would intersect there. Okay, but this is a way to do it algebraically and not graphically. Okay, so you don't have to graph it. You gotta do algebra. Okay. The reason this is more efficient or useful is that eventually you're going to have numbers that are in the hundreds or thousands or millions or whatever when you're solving a system. That's not efficient to graph that. It's no fun to graph that, okay, to find the point of intersection. This is actually better, a better way to do it, okay? All right, I want to give you guys one to do. How are we doing on time here? You guys are out of here, what, at
We're about 20 minutes away.
10:05. I always get Mondays and Thursdays like confused. It's 10. Yeah, you guys are out of here in 20 minutes. Okay. All right. Yeah. So this is 10 after. Okay. All right. So let me give you guys one. I think I wanted to do it on whiteboards, but I think I want you to have it for your notes. So do it in your notes. All right. Can I erase this?
What?
Hmm?
Which?
Yes, I want you to do it in your notes. Okay, because I want you to have it. Okay, so here you go. Here's your problem. 3x plus y equals 5. 2x minus y equals 10. Okay, and this one you could go either way. You got a coefficient of 1 here, you got a coefficient of -1 here. I would just use this one. Use equation 1 and set it up. So let's kind of do that together. So we're gonna mess around with 1.
Do we always have to solve for X or Y first? Or
Yeah, when you're using substitution, yes. You're gonna solve for one of the variables.
I know, but do you have to do one over the other first?
No. You pick the one that has a coefficient of 1. What's the coefficient here?
3,
Coefficient,
1,
coefficient,
2,
coefficient.
negative.
So you can pick either one of these guys, okay?
But it doesn't matter which one you pick first.
No. If I wanted to, I could redo this. I could write this one and do the substitution into this. But, you know, and it'll come up the same if you did the math right. All right, so what is y going to equal? What am I going to do? I'm going to do what to get y by itself here? Lydia, what do I have to do to get y by itself here?
Subtract 3x.
So minus 3x on both sides. Okay, and then I'm going to get y equals minus 3x plus 5. All right, so in other words, I messed around. This is equation 1, right? So I fiddled around with 1. So I have to substitute this into what? 2. All right, so y, I'm going to be substituting for y here. So wherever I see a y, I'm putting this in its place. Okay, and then you're going to be careful here because you see this minus y here? That minus is sitting outside the y, okay? So we got 2x minus y equals 10. So we're going to say 2x. The minus sits here. It's the y that's the same thing. So put the parentheses here, and you get minus 3x plus 5. equals 10. Okay, so do you see that? You have to be really careful right here. That minus is still sitting there. And now I'm putting in the y. N equals 10. All right. Okay, so what do I need to do next?
You're gonna add 3x plus 2x. You're gonna
Don't you simplify the parentheses?
I gotta simplify the parentheses. I get that minus there. That's really a little invisible -1 in front of it. I gotta distribute that. So I'm gonna say 2x, that comes down, -1, this is really like a -1 times -3x. What is that gonna be? Positive, so it's gonna be plus 3x. -1
Minus 5.
minus 5, yes, equals 10. All right, now what?
Add the
Like terms, okay, and I get 5x minus 5 equals 10. All right, and what do I do next, Madeline?
add 5 on both sides.
Add 5, and I get 5x equals 15. Divide by 5, divide by 5. X equals 3. All right, am I done?
No.
I need an XY pair, right? So what do I do next? David, what do I do next?
Now you need to find y. So you can
Mhm.
plug in the three into the x in that equation.
Yep. So I say -3x, the x is now 3, plus 5, y equals -3 times 3 is what, Ashley?
-9.
-9 plus 5, okay, and then y is going to equal -4. Okay, you guys good on that? Okay, so, hold on, we got to, should we do this next one? I'm trying to figure out. Okay, this is what we're going to do. We're going to do this last example because it's kind of hairy, and then we're going to do whiteboards the rest of the time. Okay, so let's just do that last example because then I want you to, you'll check how to do this. You guys have this for your notes? Okay, so let's do example 3. This is an example of why graphing is not a good way to approach this system. Okay, so David, would you read the top of example 3?
Museum admissions in one day, the National Civil Rights Museum in Memphis, Tennessee, admitted 321 adults and children and collected $1,590. The price of admission is $6 for an adult and $4 for a child. How many adults and how many children were admitted to the museum that day?
Okay, so this is a word problem that's doing linear modeling, okay, and we're going to pull two, and it's going to be a linear system. It's going to have 2 equations, okay? So there's going to be one equation, about numbers of people, okay? And then there's going to be another equation about money, okay? And it's also like a mixed problem. So a mixed problem is usually best modeled in what form of linear equation? Standard form. We're going to say X is going to represent adults, okay, and we're going to say Y is going to represent children. All right, now what's the first thing they said about numbers of people? They said how many people went there?
321.
Okay, can I do an equation that says, okay, if this is representing number of adults, this is number of children, what equation can I set up that has 321 in it that shows the total number of people?
X plus y equals 321.
All right, good. X plus Y equals 321. There's your first equation. All right, now I need my second equation, which is about money. How much was it for an adult to get in?
$6.
So, and then how much for a kid?
$4.
Okay, and then the total amount of money they raised was,
1,500.
okay, so what's my second equation?
6x plus 4y equals 1,590.
Yes. Okay. All right, so now we got ourselves a system. Okay, and we're going to use linear substitution. Okay, I got equation 1, I got equation 2. Which one of these has variables x and y with a coefficient of 1 or -1? Okay, do you guys want to solve for x or y? Doesn't matter to me.
X.
Okay, so if I'm going to solve for x, what am I going to end up with? Okay, I got to isolate the x, so what should I do, Savvy?
Subtract Y.
So I'm going to subtract y from both sides. So x equals 321 minus y. All right, so what's my next step? Madeline, what do I need to do?
And then,
So I've solved for x in equation 1, so now I know what I need to substitute.
Put that back in.
So what am I putting back in?
300 minus Y.
Okay, into wherever I see an x on the second equation. But that 6 is sitting out there, so I'm going to leave the 6 there, put a parentheses, put this 321 minus y in parentheses. So that's my new x plus 4y equals 1,590. All right, what's my next step? Distribute the 6. Okay, so Gifty, do you have that? 6 times 321, what is that?
1,926.
926, okay, and now what? Now what do I have to do next?
Minus 6Y.
Minus 6y plus 4y equals 1,590. Okay, David, what do I do next?
Now you simplify the equation
Mm-hmm.
and add the y's together.
Okay, and what am I going to get?
Negative 2y.
Yeah, minus 2y equals 1,590. Okay, and Asher, what do I do next?
You subtract 1,926 from each side.
Yeah. Okay, so this goes out. I get a negative 2y equals. Okay, so somebody tell me what that is.
Negative 336.
Negative 336. Okay, now what do I do?
Divide by -2.
Divide by negative 2. Divide by negative 2. And then y, which is my number of children, is going to equal what? What's negative 336 divided by 2?
117.
Yeah.
118.
Is that right?
No.
Okay,
168.
okay, all right. Okay, 168. Okay, so this is telling me how many kids I got. We have 168 kids. So y equals 168. How can I figure out adults now? Well, I know this, right? X equals this.
You gotta put Y in there.
Yeah, so x is going to equal 321 minus 168. So what does x equal?
153.
153. All right, you got it? All right, this would have been a bare tick graph. Okay, and you could have done it on your calculator, but it'd still be kind of, I mean, you'd be playing with that, your axes and all that sort of stuff to get the, intersection and stuff like that, and it'd be tricky. So algebra is kind of the way to go on this. All right, now, you guys get your whiteboards? Okay, and you guys can work in pairs or groups together.
Should we keep our books open?
Yes, because I'll give you a problem out of the book, okay? I want you to do number 14. Number 14 on page 399. Okay, you can do that on your whiteboard. You have to write a little bit small.
Yeah.
You might have to use both sides, okay? Because it is a lot of math.
And number 14.
Number 14.
Let's use a number 2.
Yeah. I'm sorry for it.
I'm gonna do 2.
I'm sorry.
I have a 1.
Yeah,
That's
so
what we're supposed to do.
I feel like having two results.
For x.
Isn't that? Yeah, it's A and B.
This one's A and B now.
Oh.
The variables are different, but
14.
14 on page 399. All right, and I'm gonna come around. see how you guys do. Where'd you go? Good. Why don't you try, why don't you try 18? Okay, so if you get to 14 and you finish and I check it, you can work on number 18. Yeah, but don't erase until I check. Okay, now you gotta do this alphabetically. Okay, so this is correct, that's correct, but do A, you gotta do A and B. Okay, so that's kind of the convention. Yes, you got it. Yes, you can start on 18. And you got -2.
Oh, I need to solve for this. So you got that, and then I substitute it into that.
So
Oh, yep, so you get that, that's right. And then okay, so where did you, this one right here? So now you're gonna plop that A in there and solve for B.
So when we have
But you
problems.
somehow, wait a minute, this is, you lost, no,
I'm gonna do
something's wrong here. Okay, you subtract
Yeah,
that,
don't
you did
forget
negative
to
one,
add
negative one.
It's still part of the equation. The 3B. Oh.
Oh, I saw for A, that's fine, never mind.
It is like 30%.
And when you do this, you do it alphabetically, show it as a point, this is correct, and then when you would write it like as a point, you're gonna do alphabetically, so A is gonna come first, and then B,
Yeah,
kind of
you
like that,
just substitute
okay?
here first. And then
All right, now, okay, that's it.
Which one are you doing?
You're doing 18 next.
This so far.
Okay, yeah, okay, you got that one already? Yep. Okay, and then do 20. Just tearing it up.
Where you at?
Lydia, did you get number?
it was, what was it, -2 and 1 or something?
Yeah, did you get it?
Is this the one, right? Because this is like invisible -1, so that would make these this positive and this negative.
Uh-huh.
So this is right.
I think so. I haven't done it yet, but what I see right there looks correct.
So how would you say like this would be? in your
CD,
homework?
so you're just gonna do it in
I know, but like when you're doing it in your homework, it's a lot to write. So what do you think would be the most organized way?
kind of what you're doing, but I would, you're kind of doing this top down, so you put your two equations, then I would number them, 1, 2, and then I'd say, figure out which one you're fiddling with. I would put the number down, which one is it, rewrite it, and then write the second equation again and substitute into it.
Is this right?
That is right. Work on 18 if you get,
That
if
was
you get,
18.
was that 18? Work on 20 if you got 18 right. Okay, yeah, so you got something wrong, that's correct. So, well, no, it's okay if you do it differently, it's just gotta be right. So which one did you substitute in? You did this one. So you solved for D, right? So I bet you guys, okay, so this is good. So this is good. And where did you substitute that in? You did, okay, 4C, but you're putting it, this is plus, see, plus D. So you drop that, so now you're, okay, so first of all, if that was multiplication,
So
then
we
it'd
can
be C
just go
squared,
straight into the
okay.
second problem.
Okay, so that's 4 plus.
So should we do 4 plus 2?
Yeah, because you're gonna end up with this. So you can get that,
Just do after 20.
okay, okay, and, okay, there's C, yes ma'am. Okay, all right, so, where did this come from? Okay. 4C plus, okay, I don't know what I did here. 4C, for some reason, this is number 18, right?
No, this is 14.
Oh, that's 14, okay. Okay, I've got the wrong one on here, okay. So you got this. All right, okay, so you added B, okay, you got that, that looks good. Then you're putting this in here. And what is that? So this is a 5?
Yeah.
Okay, all right, looks kind of like a 9. Okay, so this looks good, that looks good, that looks good. Okay, you lost your equal.
Oh.
Okay, there you go. You gotta keep both sides, okay? So that's what happened. Okay, that's where you went wrong. So now this plus this, that's correct, minus that, equals
Okay.
that.
Okay.
Okay, now do the rest. Yeah. Yes. Okay, so do number 20, and I can tell you your answer, and if you got it right, then you can pack it up.
After 20.
Okay, here, let me tell you what 20 is. The solution to 20 is 2, 9.
If we got it right, can we just erase it?
Yes, you can pack it in. 2, 9. Okay. So I want you to finish whatever problem you're working on, okay, before you leave. Okay, so if you didn't get all the way through here, that's okay. Just finish 14, finish 18, finish 20, whatever. Finish the one you're on. Good. Okay, so erase, put your markers over here. Where's the bag of markers? They were old. Okay, markers over here, right off to both sides of the whiteboard, right there. Thank you. All right, so you guys are going to finish up that sheet. You're going to do the odds, you're going to fix the evens, and then you're going to do this homework. And you're going to work on, hopefully you've been working on midterm corrections all along.